Hi students, this is Mr. Yao. In this lesson, we are going to talk about 2.12a, where we will learn how to solve absolute value inequalities. So some prior knowledge, since we're mentioning absolute value and inequalities. When we solve inequalities, when we multiply or divide by a negative number on both sides, we need to flip the sign. That is something we have emphasized many times already. Next, something we have emphasized in the previous lesson, absolute value represents the distance from 0, which means the absolute value would always change things to be positive. Okay, so let's look at example 1 and understand that with the distance definition. If it is actually equal to 5, we would say the distance from 0 is 5. In this case, it is less than. You see the distance from 0 part does not change because that's the definition for absolute value. But in this case, it is less than 5. That's what it means. So I'm going to graph where 0 is, and I'm going to graph where 5 is. So since it's less than, it doesn't have the equal part. At exactly 5 is actually 5 away from 0. It's not less than 5. So that means I shouldn't include 5. So an open circle there. And at the same time, I also shouldn't include the negative 5. So that part, I need to draw an open circle as well. Now let's think, I need to look for some point that is less than 5 away from 0. So 4 works, or 3 works, or 2 works, and even the points in between the 0 and the 5 would actually be less than 5. So that means I should be shading this part. Same thing on the other side. Negative 1 is less than 5 away. Negative 4 is less than 5 away. That means I should actually be shading this part as well. Now if you look at all together, I'm basically having everything from negative to the right, and I'm also having everything from 5 to the left, and this is the only part that is shaded. If you think back, we have just learned not long ago about compound inequality, and this could actually be written as a compound inequality based on the graph. It starts from negative 5. In the middle part, anything in between is greater than negative 5, so this is going to be negative 5 less than x, which is less than 5. That's the compact form we have learned. And because of that format, the connection word is and. That's example 1. Now let's look at example 2. We do want to make a little change. Let's actually get rid of that 3. So we're just having an x inside. So the meaning for that is we're looking for a number that the distance from 0 is greater than or equal to 6. So let's draw where 0 is, and let's draw where 6 and negative 6 are. Since this time we do have the equal sign, that means I do have a solid dot right there. However, a point inside, these are not going to work. These are all actually less than 6. I need something that is greater than 6. So from 6, everything over here, like 7, that's greater than 6, or 8, that's greater than 6 compared to 0, or anything on this side, that's what I'm going to shade. So if you think about it, but draw them like a normal graph, that means everything to the right of 6 is being shaded, and everything to the left of negative 6 is being shaded. If you think back about compound inequality, there's only one situation where we can actually shade both parts separately, that they're not overlapping. That means we're looking for or. So the final answer, x is less than or equal to negative 6, union x is greater or equal to 6. That is our final answer for number 2. Now, well, again, what did you notice about the signs and the graphs? Well, you might have noticed if they're enclosed, then I may have a compact form. That means I'm having and, or the other way. And for the first one, when it's less than, I have and. For the greater than, I have or. So that is how we're actually going to work with inequalities, absolute value inequalities. It is actually very clear. If the symbol is less than or equal to, it's guaranteed to be and. If the symbol is greater than or equal to, it's guaranteed to be or. Now let's have a look at all the steps. Then we're going to have the steps when we talk about the examples. So first step, still same thing, isolate the absolute value, but this time we do have an extra piece. You need to make sure it is on the left side, because we're going to need to use the sign to decide if it's and or. If you actually have it on the right side, then your sign is flipped. You may not be able to decide if it's and or correctly. So next, we're going to determine if we have an intersection or union, which means we have an and or an or. Step 3, we're still going to break it into 2 pieces. However, there is an extra part again. We are going to need to flip the sign for the second case. Not just flipping the number, we also need to flip the sign for the second case. Then you're going to solve each inequality separately using using inverse operations. Then you're going to write your final answer based on the type of compound inequality type. And of course, finally, we are going to graph. Next, absolute value refers to distance, and distance can't be negative. That's something I've emphasized many times already so far. Please keep that in mind because that is the definition of absolute value and is very important in solving. A helpful hint, you can treat the absolute value like a gift. So you need to get rid of everything around it to get to your gift, but then you also need to get rid of the wrapper so that you can see what is inside. So now let's have a look at some example with steps. Step 1, isolate the absolute value and make sure it is on the left side. So it is isolated and is on the left side. There's nothing in front of it, nothing on the back, and nothing below. So that step is check. Next, you are going to determine if you have an intersection or a union based on the inequality sign. Here's my inequality sign. It is less than or equal to, which means it is going to be and. Next, we're going to break it into 2 pieces, 2 cases. First case, you just remove the absolute value and solve. So first case, 3 plus 4, x plus 4 is less than or equal to 0. However, for the second case, we're going to have x plus 4, but this time, remove the absolute value. I did remove it, and also flip the sign, so it's going to go the other way, and also make the number the opposite or negative of what it was. So in this specific question, do we actually have negative 0? The answer would be no, so that we are just setting it greater or equal to 0. Next, you're going to solve them separately and write your final answer as compound, then graph. So let's start solving. This one is going to give you x is less than or equal to negative 4. This one is going to give you x is greater or equal to negative 4. Now it's time to graph. For the first one, negative 4 is right here and is pointing to the left. I'm going to shade everything over here, including negative 4. And then we have x is greater or equal to negative 4. That's going to be pointing to the right, but it also starts from negative 4. So if you're ever wondering, I shouldn't actually shade that part. You're like, wait, then what am I looking for? Well, the keyword is and. So you are looking for overlap. In this case, one pointing to the left, one pointing to the right. They don't have big portion of overlapping. However, they do have a point that they share, which is right here. So the final answer is x equals negative 4. So that is that is example 3. Next, example 4. Step 1, same thing, isolate. It is isolated, so we can get to the second step. It is greater than, that means I'm using or. So then I can get to step 3. I can start separating the cases. Case 1, just remove the absolute value and copy it down. Or, second case, flip the sign and flip the number. So this one you will get x is greater than 25. Or, this one add 20 on both sides, x is less than 15. Start graphing. 15 is right here to the left, 25 is to the right. And we're going to shade each one of these sections because the connection word is or. Final answer, x is less than 15 union, x is greater than 25. That is our final answer. That's example 4. Next, example 5. First, this is my box. I need to make sure the box is by itself before I start solving anything. That means I need to subtract 5 on both sides first. So the absolute value of x minus 4 is actually a 5. Is actually less than or equal to 5. Because it has the sign less than or equal to, that means that it's going to be and. I'm going to separate my cases now. First case, x minus 4 is less than or equal to 5. And for the other case, I gotta flip the sign, and flip the number. So this is going to give me x is less than or equal to 9. This is going to give me x is greater or equal to -1. So -1 to the right, 9 to the left. And we're going to shade the overlap, which is the middle. So final answer, -1 is less than or equal to x, which is less than or equal to 9. That's example 5. Now example 6, same idea. You want to make sure the box is isolated, so add 4 on both sides. 3 plus x inside absolute value is less than 3. And again, same thing, because it's less than, the connection word is and. So we have 2 cases now. First one, oh, I added 4, so that actually be a 7. First one, 3 plus x is less than 7. And second one, 3 plus x is greater than -7. Again, flip the sign and flip the number. So the first one after solving, x is less than 4. And the second one after solving, x is greater than -10. No equal sign, so all circle -10 to 4. Since it is and, less than 4 is going to be to the left. -10 is going to be to the right. So I'm going to shade the middle. Final answer, -10 is less than x, which is less than 4. So that is compact form. That's number 6. Number 7, same thing. It is not isolated, so I'm going to need to subtract 2 on both sides to make it isolated. Then I got 3x minus 3 is greater or equal to 13. Case 1, 3x minus 3 is greater or equal to 13. And since it is greater than or equal to, that means my connection word is going to be or. Now the other case, 3x minus 3 is less than or equal to -13. So 3x is less than or equal to a 10 if I add 3 on both sides. So x is less than or equal to 10 over 3. As for the other one, and it is actually a negative. And for the other one, add 3 on both sides, I got 16 on the right side divided by 3. X is greater or equal to 16 over 3. So let's say 10 over 3, negative is right here, left, shade. And on the right, it's going to be a positive 16 over 3 to the right. Okay, final answer. X is less than -10 over 3. Union, x is greater than 16 over 3. Both have equal signs, actually. So that is my final answer. Number 8, I need to keep the box isolated. But again, that 3 outside, we do not distribute it. And also, it is being multiplied with the absolute value, so I need to divide both sides by a 3. So the box now is isolated. First case, 1 plus 2x is greater than 3. After solving, x is greater than 1. Now 2. 1 plus 2x, it is less than -3. So that means 2x is less than -4, so x is less than -2. I'm going to start graphing. -2 is right here, 1 is right here, greater than 1 pointing to the right, less than -2 pointing to the left. Shade them. Then final answer. X is less than -2. Union, x is greater than 1. So that is the final answer for example 8. And that is everything for 2.12a. Thank you.